输出电压跟水库电压的关系式，就靠电阻的力量。然后如果这是可变电阻，可变电阻是可以调整，就可以在里面调整它的放大倍。所以这就是，Yeah， 好，可以吗 ？Okay, so right now you see the power of operational amplifier is by just using different values of resistors, we can do these arithmetic operations, and we can amplify a voltage by certain value by just tuning the resistance. So, and the operational amplifier remains the same. So we don't need to change anything about this. We just need to change the values of resistance. So we often use a variable adjustable resistance at certain place, and then we can change the gain. We call it closed loop gain because it is always operating in a closed loop configuration. OK， 它基本上永远都是闭回路的架构，然后我们只需要我们不用动这个运算放大器本身，我们都不需要去改变，我们只需要去改变它的连接的电阻，还有它的这个架构，我们就可以去调整，我们就可以去将一个电压放大，我们可以放大直流电压，也可以放大交流电压，我们可以做电压的相减，还有相加，然后都不用动，我们只要去接线，还有搭配电阻值就好了。所以运算放大器我们很常使用运算放大器。Okay, so it is often used, but for you don't need to derive this. You will be in the exam. You will be given all those values. Okay, so remember golden rule, Ohm's law, and KCL, and you should be able to solve it. Okay. So any problems here? Okay, if there's no problem, let's look at another structure. Here. Okay, so this is called integrator circuit. So from its name, we know it's doing integration. This configuration, it will integrate the input voltage. So why do we need to do an integration? Because for acceleration signal, for accelerometer, we call it accelerometer. I always spell it wrong. Accelerometer. Accelerometer. Let me check. Accelerometer. CCLER. Accelerometer. We always use this to measure vibration. We use accelerometer, and its output will be a voltage, very small voltage. And because this voltage is proportional to acceleration, so if you want to receive velocity, we need to use an integrator because the integration of acceleration is velocity. So this circuit is also used very often. 好，那我们这个叫做积分器。那积分器呢，我们在 feedback 的地方放一个电容值。
理论上，实际上可能还要放一些电阻，但理论上就是一个电容，就是可以达到积分对我们的输入电压积分的效果。这个常用在如果我们用一个加速度计量测一个物体的振动的时候，我们量到的电压其实反映它的加速度。那我们此时呢，我们需要将电压积分将加速度积分才会得到速度。那速度积分得到位置嘛，那我们就是用积分的方式得到速度 ，OK？ 但 OK，yeah. So we also often use this structure. So theoretically, so we have this structure. So what can we do? Again, we apply golden rule. So golden rule is, let me write it again. Suppose this is A, this is B. I want to use blue because blue is easier to erase. So golden rule. Golden rule again. Golden rule tells us VA equals VB, and IA equals IB equals 0. So this is IA, this is IB equals 0. So we have I1 plus I2 equals 0. In this case, VA equals VB equals 0 because B connects to the ground. Okay, and so we have a capacitor. We put a capacitor in our feedback loop, and we know VA is 0. So we assume that VO is larger than 0. So we assume this is positive and this is negative. So the current, the definition of the capacitor current flows from positive to negative. Remember, because we always assume a capacitor, this is DC and this is IC. The current flowing from the positive to negative for a capacitor. And so we have I1 equals VI minus 0 divided by R, right? And how about I2? It's C dVC dt, right? And equals 0. Okay, and dVC, so we have VI divided by R plus C times dVC is the VO minus 0 because VC is VO minus V0. This is VC, and then positive, negative, VC. VC is VO minus 0 to T equals 0. So we rearrange it a little bit. So we have what? We have, so let me rewrite. So this is so I put here we have minus, this is 1 over RC times VI equals dVO dt. Okay, so right, dVO dt, and then we have this. We rearrange this when 1 over RC dI dt equals dVO. So we can integrate from 0 to t. So this is 0 to t. So this is VO0 VOT. T. So this is VOT minus VO0. We have VOT equals 0 to t minus, I put minus 1 over RC 0 to t VI, let me set it. Yeah, so this is the result. So remember, VI is a time function, so I make it VIT here, so please put VIT minus 0 and VIT and VOT minus 0. I want to emphasize it's a time function. So this VIT, VOT. Okay, it's not a constant. Okay, so you need to, yeah, in this case, because you need to, what you need to memorize is if you replace the feedback resistance with a capacitor, it will become an integrator. Okay, it will integrate the input voltage, and because this input voltage still connects to its inverting terminal, it's a negative terminal minus. So it has a negative sign. It's still inverting. Okay, so this is what you need to know. 好，那这个这里是一个积分器吼，那你所需要知道的就是你要做积分的话，就是把我们的 feedback， 我们的回授电阻 RF 用一个电容取代。那你也是一样用 Golden Rule， 但是你的 I2 啊，必须要去用这个电容的电压电流关系式来取代，它就是有一个 C dV C dt， 然后取代了之后，那你会推导到你的输出电压会是输入电压的积分，然后我们又注意到我们的输入电压它接在这个反向的地方。我们说负是反向，所以你的输出也是反向，有个 minus sign， it means 180 degree phase difference. We call it inverting. Okay. Any questions? You can memorize this formula. Yeah, because it's quite simple. It's 1 over RC. You can memorize this formula. Minus 1 over RC and integration of VI. Okay. Any questions? 对，你可以稍微记一下，因为这很简单。好，那我们看一下这个例子。 Does anyone need more time to write this down? No? Okay, so we look at this example. Okay, we look at this example, but this is already given, so let me lower it down. Yeah, the answer is given here, right? Yeah, the answer is given. Okay, what does this say? It says that consider the integrator with the square wave. This is called square wave input signal. If R equals 10k ohm, C is 100 mu F. Sketch the output waveform. So so we have this. So because it's piecewise continuous, 片段连续, so we need to consider the first is Vi is 5. So you make integration. First, you apply this formula. If you apply this formula, you will have this minus VIT times T. And between 0 and 1 seconds, this is minus 5, right? Vi is 5. So VO equals minus 5 times T. So it has a negative slope until this is minus 5. And then between 1 to 3, Vi is minus 5. So apply this VO equals 5 times T. So it's 5 times T. So 5 is positive slope until it reaches 3. It reaches 5. So that's how we derive it. So in the exam, you may be given this, and then you are asked to draw. If you are given an integrator circuit, and you are asked to draw the output. So the input is square wave. This is the output is triangular wave. Yeah, this is the integration of the square wave. 好，那这个就是这个例子，它告诉你输入电压讯号，它是个方波。然后它经过这个积分器之后，要你画出输出电压。那这一题呢，我们就是直接用这个公式。那我们也假设呢，这个 VO 0等于0。那画出来之后，你的公式最后会是 minus 负 VIT 乘上 T。那因为这个方波呢，中间是不连续的，我们没有办法来算，你们只能算0到1秒，然后它的值是5，然后此时 VOT 是负5T， 所以0到1秒是负5T， 1到3秒呢是5T， 所以1到3秒是5乘上 T， 然后过了2秒嘛，所以你知道1到3秒它会上升10，然后又下来就是你又 VO after 3 seconds and then VO, the output voltage is minus 5T, so it's minus 5T until 5 seconds and it becomes positive again. So that's how we draw this, how we solve this problem. So any questions? So this is called integrator. Okay, the integrator is to replace the feedback resistance with a capacitor. Okay, and so we have integrator, we also have differentiator. Remember we all apply on the inverting amplifier, right? For the integrator, you just replace the RF in an inverting amplifier. Replace RF with a capacitor. For differentiator, we also look at the inverting amplifier and replace the input resistance with a capacitor. 好，那我们如果这是电阻的话，那如果这是 RI 的话，那这个架构就会是一个反向放大器嘛。所以我们的积分器、微分器都是由反向放大器来推导的。那来做改变的哦，所以我们可以预料 VO 一定是负的什么什么 VI， 那这里是 VO 会是 VI 的微分 ，OK， 如果那 OK，the same thing， replace the capacitor， replace the RI， the input resistance by a capacitor. So by KCL, yes, we apply golden rule again. So we have I1 equals I2. So by using golden rule, so let's see, by golden rule, we know I1 equals I2, and this is zero bound, right, by golden rule. So I1 is C the VIT dt, right? Because the VC equals VIT, okay? And then equals I2 equals 0 minus VO. 0 minus VO divided by RF. Okay, so we have this. VOT is just minus RF times C times the VIT dt. Okay, so this is simple, right? So you need to know, you may need to memorize this equation, or you can derive it because it's really simple. And you may be given a signal, and you are asked to draw the output. It's very similar to the previous one. So we call this differentiator. 我们说这个是微分器。And they are all derived from an inverting amplifier. 它们都是由反向放大器来改的。Okay, so integrator is replace the feedback resistance with the capacitor, and for differentiator is to replace the input resistance by a capacitor in an inverting amplifier. Okay, so any questions? Okay.
.我们有同学说准备来不及，所以只有1个礼拜，所以我们今天不考试，我们今天点名，下礼拜再考，点名当小考，等一下点。And this, again, this potentiometer is this. This potentiometer is this. It's this stuff. So, but in the next semester we will work on this, because in the next semester in the lab you are going to use this operational amplifier. So you will need to calibrate it first. So because I kind of forgot how it connects, but don't worry about it. You will do that. 好，就是上次讲到的校正的问题啊，就是当你
你接通这个运算放大器的电源的时候，即使你还没有给输入电压，因为它制造上的关系，它的输出有时候会已经有电压了，可能是正的，可能是负的。然后这时候就是你的 offset null， 你的2个 offset null， 然后跟负极接一起，然后可以用一个可变电阻来调整，你可以把它调到0的位置。OK， 这个下学期大家在实验课的时候会做到。然后这个接角我有点忘记哪个接角，但没关系，实验课的时候接就知道。OK，and we want for page 40. For this, I won't test you. 就是 so for this, I won't test you. You won't be tested on how to draw a circuit. You will be only given this kind of questions. For example, there are two operational amplifier together. How do you calculate it? So this one is simple because I already write down. Because you can see they are independent. Because the characteristic of operational amplifier, it has a very large input impedance, so you can calculate it independently. So for this one is a buffer. We also call buffer voltage follower. So if you know the structure, you can immediately know it's a buffer. If you don't, you just look at this operational amplifier only, and you can derive it by using golden rule. So you know, since they share the same ground, and once you know it's a buffer, or we call it voltage follower, we know this is 2.5 volts. Okay, and also here, here it is a non-inverting amplifier. It's a non-inverting amplifier. 是吗？Non-invert. Yes, it's a non-inverting amplifier. Okay. Yes, it's a non-inverting amplifier. 它是个非反向放大电路。So this is the gain, closed loop gain for a non-inverting amplifier. Because you know right now this is ground, you provide voltage at the positive terminal. This is non-inverting terminal, and then so you can calculate the closed loop gain for this. So the overall VO2 equals 5. This is 2.5. 2.5 times 5, and okay, this is a little bit weird. 等一下 VO2 equals 5 times VI2 is 5 times VI1. Yes, it's right. It's 12.5 volts. Okay, so you may be given this kind of problem is we put 2 operational amplifier in cascade or in series. 好，那你们会遇到就这种问题，就是你很有可能是2个运算放大器串联，那你其实可以把它们独立看。那你如果够熟的话，你一看就知道这是一个buffer， 或是我们称作 voltage follower， 它的 output voltage 会等于它的 input voltage， 而且它没有反向，所以你马上就知道这个是2.5伏特。然后再来你看这里，那你可以比对，这是它把电压连到非反向端，然后这是我们的反向端有2个电阻。那如果你对这个架构够熟，那你可以马上知道这个它的 gain 是 1 加 RF 除以 R2， 那你可以把这个 gain 算出来，然后你的最后的输出电压就是5，这边的输入第一个的这个的输出5乘上它的 gain， 2.5乘上它的 gain， 然后是12.5伏特。OK，and if you cannot recognize the configuration by using golden rule， 如果你不能马上看到它的架构的话，请用 golden rule 搭配 Ohm 定律还有 KCO 推导。OK， 好 ，So this is you will be you will focus on this kind of questions. You are given a configuration of operational amplifier. You will be given the value of the resistance, and you are asked to calculate the output voltage. Okay, they may be in series. Okay, and so skip. If we don't talk about it, it won't be on the exam. So this is how you design the circuit. And one more thing, one type of problem is this. Okay, so this is inverting, right? This is inverting amplifier. This is inverting. So because you connect voltage to the inverting side, you have R1 is input resistance, R2 is output feedback resistance. So you may be asked to calculate I1, I2, IO, IX, and VO. Please try it on your own. I already give you the answer. This is inverting amplifier. You should be able to calculate it by using golden rule. Okay, 这一题计算。And last question, last problem today is what I want to introduce these configurations. Okay, and if we have time, we may talk about this instrumentation amplifier, but it's also used very common, but I prefer to come back here maybe in the end of semester. Okay, so 这个叫做 instrumentation amplifier， 这个也是一个很常见的架构。但身为机械系的同学，其实但这个架构 ，this configuration has been implemented in the hardware， 在硬体里面就已经实现这个架构，所以你们不会 you don't have an opportunity to design this by yourself， 你们 机械系的同学不会直接去设计这个东西。Okay, so we will go back in the end of semester. But before you go today, we need to introduce the final problem, final example of this chapter, which is this configuration. Let's look at this configuration. You have an input voltage. It connects the inverting terminal, negative terminal. And it has a feedback, but usually we just have a feedback resistance. We just have one feedback resistance only. But in this configuration, it has 3, and it also connects to ground. So what happened? So because the input voltage connects the inverting terminal, we know the output will be minus times a value times input voltage, right? Because it's inverting. It's on the inverting side. And here positive just connects to the ground. So this configuration has high gain magnitude without resorting to a wide range of resistor values. Okay. What does that mean? It means, how about let's solve this? Let's solve the relationship between, yes, you are given resistance value. How about we calculate VO first? So if the input voltage is 1 volt, what's the value for the output voltage? Okay. So, golden rule, the same thing. The voltage here, V1 is 0, and we know this is 0. So we know I1 equals I2. So let's solve this step by step. So by golden rule, we know V1 is 0. And I1 is 0. Okay, this is what we know from golden rule. And so can we solve I1 if we are given V in is 1? Yes. So I1 is V in minus 0 divided by 1k, which is divided by R1, which is 1 divided by 1k is 1 milliamp. Okay? OK， 那你说？啊？哦，好，等下再加分，加分 ，Yeah， OK。So this is Vi is 0, V1 is 0, okay. Okay, I is 0. So you have I1, and then can you calculate I2? Because I is 0, so we know I1 equals I2, right? So this KCL I know 1. I know 1. We know I1 equals I2. We know I2 equals I1. I2 equals I1 equals 1 milliamp. And then can we calculate V2? If we know I2, yes. Because we know V1 is 0, and so V2 is V1 minus R2I2, right? Because right now we already know the direction of current, and direction of current the current always flows from high voltage, high potential voltage to the low potential voltage. Okay, so high electric potential to low electric potential. So we have this equation. And so V2 equals V1 is 0 minus R2 is 10K times I2 is 1 amp. So V2 is minus 10 volt. 还有问题吗？ V2 is minus 10 volt. So, and then we want to solve I3. So we have, so step by step. So I3, since we know V2 is minus 10, and so I3 is 0 minus 10 divided by 1k. This is what? 10 divided by 1k is 10 milliamp. This is 10 milliamp. Yeah, this is 10 milliamp. So, and then we can calculate I4. So I4 is I2 plus I3, which is 1n plus 10n is 11n, 11 milliamp. And finally, once we have I4, and so we can calculate VO. So VO equals V2 minus R4 I4, which is V2 is minus 10 minus R4 is 10K, I4 is 11N, is minus 10 minus 10 equals minus 120 volts. Okay, so I hope you can follow me. 好，其实 我用的也只是，我并没有用到什么新的公式，我只是慢慢的从用 Golden Rule 用黄金法则，一直推电压电流，电压电流，电压电流，然后用欧姆定律，然后我把每一段的电流还有每个节点的电压都找出来，然后我可以一步一步的，so you see me derive from V1 is 0. I derive I2 first. So once I know I2 and R2, I can derive the value of V2. And once I know V2, because this is from a given resistance, I can calculate I3. And from I2, I3, I can calculate I4. So I know the voltage here, I know R4, I4, I can derive VO. So this is nothing special, just more steps. Okay. Okay, any questions? Okay, so you will also implement this in the lab. So why this configuration is better is, for example, if we want to amplify the input voltage, by a very large gain, it is minus, but how can you make it? But we can connect to an inverting amplifier at the output, and then to make it positive, right? So, but you need to have a very large gain, and if we do not apply this configuration, we can apply an inverting configuration. You need a resistor which is 1k ohm. You need another resistor which is very large, 120k ohm. Okay, so to reach this minus 120, if V in is 1 volt, to reach 120 volt, you need a very large resistance here. But if you notice in this configuration, we only use 2 kinds of resistance. One is 1k ohm, another is just 10k ohm. And we can have a very large gain. So by using this configuration, we can use a smaller resistance to reach a large gain. And if we want to make it positive, and then we can connect to an inverting amplifier, and then to make Ri equals Rf, and we can make it a positive 120 volt. Okay, so 这个架构看起来比较复杂，但其实它的好处就是它可以用小的电阻值达到一个很大的放大倍率。这个也是常用的手法，就是我们可能如果要放大120倍的话，那我们要有一个1k 欧姆，我们要找到一个120k 欧姆的电阻。那有时候电阻不是那么好找到，而且越大的电阻值也不是那么好买，也比较贵。那其实就可以用一些组合来产生一个很大的增益 ，OK。然后如果说你要是120伏特是正的话，再在后面连接一个反向放大器，让 input 让 Ri 等于 Rf， 那它就变正。OK, so that's the trick. So any questions? If no questions, let's call the attendance, and it is counted as one of the quiz. And then we finalize operational amplifier, I will give you homework exam maybe by this weekend. I will give you homework by this weekend, not homeworks. 好，那我们点名一下，那点名当小考。好，今天是5月18。Brian Early， 黄玉成，蔡成佑，吴炳焕，吴黄贤。OK， 蓝丽蓉，林家辉，陈冠豪，吴炳赫，林景义，彭佩伦，余泽峰，许元春，吴承汉，赵百祥，叶书成，何公凯，黄玉祥，童博豪，黄元俊，张成玉，吴俊霖，陈昌义，吴奇瑞，朱鹏瑞，朱明伦，邱子清，吕恩杰，洪一斌，陈宇志，张浩君，陈彦荣，刘平安，吴家爱，张明义，陈立凯，李长生，啊，你在睡觉？陈立，好 ，OK， 好，那 if you have any questions, you can stay. If you don't, you can dismiss. And see you next week.
还有加分的来，要加分的来，快点！有加分的来，不是我说什么？上面有错吗？来，哪里错？在哪里？都包好少起。气很容易被我们掌握。好，加这什么等等，好2分，加，大家都加。昨天有加1分，有好，加。好，我们先 OP 就讲到这边。你昨天怎么那么累？不会的啦，这没有很难，看看影片问问同学。你在干嘛啊？哦，手机有什么好看的？啊，什么有趣？跟我讲一下。然后，没考7、8场就回家。没有很难，没有很难。这新版的6版，5号，新版，然后就是IJ，那你把它留给我吧，然后什么就会联系到书上。对，但不会那么太考，会勾几题。 但题目可能没那么多，所以不用太担心。好，我们下次是考上次说今天要考的范围，对。然后这个之后再说，因为其实我们快期末考了，知道吗？对，到期末马上要考了。对啊。可能再顶多1、2次小考而已，因为就要期末考，16周。
我问一下，刚才说有一开始上课说这个 Y 跟 U 那到底是这是电子前后的电子？
前后的电压，输入跟输出，我们只是假设是开路争议，就是把 U 放大 A 倍 ，Y 等于 A 倍的 U， 所以我说 OL 是 open loop，OL U， 对啊，就是 U 是输入 ，Y 是输出，然后这是开路，那我们就是把它闭路，把一个负 Y 乘贝塔加到 U 里面。
这个贝塔就是你的那个。
对，就是我们可以去调的，不是 F， 就是我们只是统称啦，就是贝塔。但是这个贝塔是当我们的开路争议无穷大的时候，就会跟开路争议无关。它的闭路争议啦，就会是贝塔分之一。
所以开路它是多大？
很大，但我理论上不可能有什么直到无穷大，是非常大。然后，所以当开路非常大的时候，它的整个 Y 跟 U 的关系会是贝塔分之一。那我们可以借由设计变组的排列去调贝塔。对啊，对，所以。